In this section, we're going to talk about quadrilaterals, and we'll start off by what a formal definition is for a quadrilateral. Well, we need to start with 4 points, A, B, C, and D, in a plane such that, all right, well, you cannot have 3 points that are collinear. In a quadrilateral, among these 4 points. No pair of open segments, so maybe I could have drawn the open segments like that, the segment AB, where it does not include the endpoints. No pair of open segments have any points in common. If that's the case, then this set that we're going to call triangle ABCD, which is line segment AB unioned with line segment BC unioned with CD unioned with DA, is a quadrilateral. And the vertices are simply these 4 points. And the sides are these, only they'll be closed segments. So AB, BC, CD, and DA. So we're drawing a picture of one possible quadrilateral, A, B, C, D. What would the diagonals be? Well, the diagonals would be these two. AC, that segment, and BD. Those are the diagonals, the 2 diagonals of this quadrilateral. And the angles, which we could just call angle A, angle B, angle C, and angle D. I'll be a little more specific on this. I will call it DAB. That's this angle, which I would normally just call angle A. Notice A is in the middle. And on the next one, I'm going to put B in the middle. So ABC. ABC, that's this angle. And then BCD, which also could just be called angle C, the middle one. And the 4th one would be CDA. Okay, that's the definition. Now, one little caveat here. We are not going to deal with complex quadrilaterals. A complex quadrilateral would be one like this. Where we specifically have the diagonals crossing. So it would be A, B, C, D. We're not going to deal with those. So we're just going to ignore those for now. All right, number 2. In a quadrilateral, this is just some terms we need to become familiar with. 2 sides are adjacent. Well, you can probably figure it out. This side is adjacent to this side. Well, and also this one. This side is adjacent to this side. This side is not adjacent to this side. Okay, so with that kind of explanation, 2 sides are adjacent. You could also call them consecutive if they share an endpoint. An endpoint, which I'll say a vertex. Another name for it. One of these corner points up here. So AD shares the point A with AB. AD and AB are adjacent sides. 2 angles are adjacent or consecutive, and what do they have to share? You took this angle and this angle. Well, they share this segment. they would share a side, which is a line segment. Two sides are opposite if they have no common vertex. No common vertex. Actually, if they are opposite sides, they share no points in common whatsoever. All right, number 33. A convex quadrilateral is probably something we're already familiar with. We know what a convex set is, and a convex quadrilateral is a quadrilateral whose interior, so not the quadrilateral itself, but inside it is a convex set. And here's an important note, characterization. If the two diagonals of the quadrilateral intersect at a point that happens to lie between both pairs of opposite vertices, then the quadrilateral is convex. We'll draw a picture of that in just a second. And along with that, we'll draw a non-convex quadrilateral. So here's an example of a convex quadrilateral. And notice that if you draw the diagonals like that, they intersect at a point right here that lies in between both pairs of opposite vertices. This point is in between these two, and it's also in between these two. How about a non-convex? Something like this would work. I'll put non-convex. This one was convex. And then one that I'll give kind of an example of another one that is not something we're going to talk about. This doesn't even follow the definition. These 4 points, if you connect these three are collinear. So effectively, all you have is a triangle. And if you remember from the definition, no 3 points of a quadrilateral are collinear. So we can't have that situation.